Alright, so we're going to start chapter 3. Our first section is in chapter 3 is talking about perfect squares, which should be review, square roots, which again is review, and then square equations, or quadratic equations is what they're technically called. So let's get started. Let's refresh ourselves. A perfect square is the answer to a squared problem. So in other words, and we had a more technical answer, but if I have 2 squared, the perfect square is the fact that it is 4. So our perfect squares are 1, 4, 9. Helps if I can write today. 16, 25, 36, 49, 64, 81, 100, 121, 144. That's 12, so 13 would be 169, 14 would be 196, and 15 would be 225. So those were our perfect squares, right? A square root looks like this, and when I take the square root of a perfect square, it's what number times itself gives us that number inside the square root. So, yeah, I wish I could be more technical today, but I can't for some reason. So, for instance, if we take the square root of 4, that equals 2. Or if we have the square root of 9, that equals 3. If we do the square root of 10, then that would be approximately 3.1, 3.2 something, etc. Alright, so perfect squares, when we're able to, or when we take a number times itself, whatever we get, that's its perfect square. Oh, excuse me. Oh my goodness. Or the other way to think about that is if I were to take the square root of that number, then I get a whole number. That's what perfect squares are. They'll give us whole numbers when we take the square root. And the square root is the inverse of squaring something. I like that one. The inverse of squaring a number. Perfect. If I sit there long enough, I come up with it. Alright, so the new part of this lesson is solving equations of the form x squared equals p, p being any number. So consider x squared equals 4, because I think if we see it in action, then it actually makes sense. We just said that a square root is the inverse of squaring a number. So here I'm squaring an unknown. And just like when we were doing like 2x equals 10, and here we had multiplication, and the inverse of multiplication is to divide, so I'd get x equals 5. Here, I need to do that inverse operation. So the inverse operation is to do square root, square root. Yes, this is, guys, this is not hard work to show. Show this step. And so then x equals, now, we have to be careful, because I know that when I take the square root of these, I'm thinking, what are the 2 things times themselves that would equal 4? That's what I gotta think. What times what equals 4? Well, 2 times 2. But is that the only answer? What about -2 times -2? Right? That's something times itself. And that equals 4. So when we take the square root of 4, there's both 2 and -2. And so in Math Excel, you have to write it as 2, -2. For me, on a homework assignment or on the exit ticket, you can give me a plus over a minus sign. That means the positive and the negative of that number. But the answer is technically 2 and -2, because if I square that negative, it will become a positive, because a negative times a negative is positive. So let's do some practice. We're going to square root. The square root of x squared is just x. The square root of 81, I need the number that times itself gives me 81, and so that would be 9, but that is also -9. So 9 and -9, or -9 and 9, or that plus minus 9. Either way, I'll accept either. Alright, so on to B. Square root. Alright, because that's the inverse of squaring, and so then x would equal plus or minus, and the square root of 49 is 7. Because 7 times 7 is 49. Alright, once again, x squared equals 16. I need to get x by itself, so I'm going to square root. And what I do to one side, I have to do to the other side, and so then I get x equals, and square root of 16 is 4, or it could be -4, so plus or minus 4. Again, you can write it like I did here, where we have the positive and the negative written, or the negative and then the positive. Either way, when you write that order, or you can give me plus or minus. Again, in Math Excel, you have to type both answers. And if you are doing this assignment and you're like, I'm getting it right, but it's counting it wrong. If you don't have both answers, that's why it's counting it wrong. So be careful of that. And when we do square roots, we have 2 answers unless we're doing something where only one of them makes sense. But when we're doing this just flat out equations with no, word problem, context, then we need both answers. Alright, so here we have fractions. And so when you're working with fractions, I square root my a squared. I'm going to square root this whole fraction. Now what that means is, if you type this into the calculator, it's going to give you a decimal, and we don't want the decimal. I'm going to have a is equal to plus or minus, right, because I know it's going to be a positive and the negative, the square root of 64 over the square root of 81. So I square root the top, I square root the bottom. So plus or minus, the square root of 64 is 8, and the square root of 81 is 9. So a equals plus or minus 8 over 9, or 8/9, oops, not G, 9th, comma, -8/9. So the only difference is I have to square root the top, square root the bottom. Now looking at B, here the first thing I have to do is make that improper. I can't leave that whole number there, so I'm going to take 25 times 10. So that's 250 plus 6 makes 256 over 25. So W squared equals 256 over 25. So here I had to make it improper first, and then we square root top, square root bottom. And so W would equal plus or minus 16 over 5. And then Math Excel would want you to turn that back into a proper mixed number. So W would equal plus or minus, 5 goes into 16 3 times. That takes 15 out, so we're left with 1/5. So plus or minus 3 1/5 would be our answer. Alright, last problem. It's our word problem. A company makes a small custom designed stamps that have a square image. And so we know that with a square, I'm going to do my best to sketch a square. but that it's a side times a side. So area is side squared. The image area has an area of 1,200 millimeters squared. Now when it talks about in A, what is the exact length, that means no rounding, no just cutting off decimals, no, like, it has to be exact. And so with square roots, unless it gives you a whole number, the only way you can be exact is to leave it as a square root. So R, if it wants the side, so side would equal, let's try this again. So we know the area is 1,200, and that would equal side squared. So to get the side by itself, we're going to do square root, which we have already done in chapter, what was that, 1? And then this, if I can try, and so if I do 1,200 square root, I end up with a decimal. And so my exact would be that the square root equals, or side equals, the square root of 1,200. And that's going to be millimeters, because we should use units. That's going to be my answer for the exact. Now, to approximate, I type that into the calculator, I hit square root, and it wants nearest tenth, so that's that first decimal. So this is what I'm seeing in my calculator right now, and it goes on, and I'm not going to write all of them, but I just want you to see some of what it is that I see, and then this just keeps going. So if I'm going to go to the nearest tenth, then my side length is going to be 34.6 millimeters. So I just took and actually found the square root of the 1,200 and then rounded to the nearest tenth. So this is very much like what we were doing in chapter 1. It's just now we don't have to use the tables, although it's not bad to practice every so often because that is a state standard. And that is solving square root equations. Until next time.